Hey everybody, so at the moment I have set up my ALB, which of course has an HTTP listener on it. So let's take a look and find out what IPs that ALB has. So I'll just run a dig to my ALB and I can see it's got those two IPs. Now if I want to see how TCP connections are being distributed from a single node out to those targets, what I would do is I would run a curl to a target, to a node, sorry. So let's run a curl to our second IP there. You can see that one goes to server 1, that's my first target. Let's run it again. It goes to server 2. Let's run it again. Server 2. Server 1. There's only two targets, so if I keep running it, we can see it seems to distribute across both of them. Now, just to try and get a better ratio, we can't really make a judgment of the ratio that it's distributing in. I'd probably want to run it across at least 100. So let's run 100 requests. Now you can see here I've run 100 requests. We can see server 1, server 2, server 1. We can't really tell exactly what ratio it's in. So I'm just going to do that. Test again. Except we're going to sort and account. So we can see 50 of those requests went to server 1, and the other 50 went to server 2. So that's pretty much that's exactly 50-50. It's not necessarily going to be exactly 50-50 when we run curls, but you can see it's going to be very close. So now that's looking at TCP only, creating a new TCP connection each time to this node. So what I would like to do is look at HTTP requests. So I'd like to initiate a TCP connection to this node and then start piping HTTP requests through that TCP connection. So the first thing I'm going to do is with NC, I'm going to create a TCP connection to that node, and you can see that is now an open connection, an open TCP connection. Now I can actually push an HTTP request through that TCP connection, and you can see the server comes back with a response of server 2. Now I can push another HTTP request into that TCP connection, and you can see we get server 1. I'll try again. You can see we get server 2. So this is a single TCP connection that we are pushing these HTTP requests through. So you can see it goes server 1, server 2, server 1. We'll try again. Server 2. And it's basically, it should be reasonably evenly distributing these requests. Now I'm just going to terminate that TCP connection. I would like to do it across more than just the probably 5 or 6 HTTP requests that I have sent in. So what I'm going to do is I'm going to create 100 requests, or the text for 100 requests. You can see if I'm just going to create that text. If I run that this small little script here, just run 1 to 100, get HTTP host and a user agent and accept, and you can see it just prints that out 100 times. So the next thing I want to do is I want to pipe that into a TCP connection. So what I'll run is I'm going to run my 100 requests, and I'm going to pipe that into a single TCP connection down here to that server on port 80, or to that node on port 80. So if I run that, you can see we're getting server 1, server 2, server 1, server 2, server 1, server 2. So it is, once again, we're seeing 100 requests this time, and it's distributing them one then the other, one then the other. So now if I just get rid of all the garbage, all of the verbose output there, I'll just do a grep server on all that output, and you can see we get server 1, server 2, server 1, server 2. So it does flick between the two, and let's just make sure that our ratio is basically 1 to 1 here. I'll run one more test, and that will be we are grepping for server, and we're just going to just do a sort and count, unique count. So if we run that once again, we get 50 HTTP requests going to server 1 and 50 going to server 2 of 100. So what that means is that through a single TCP connection, we've sent 100 HTTP requests through. 50 have gone to server 1 and 50 have gone to server 2. So I'm going to set up this same experiment on my NLB, and we'll just compare those results.